I want to show y'all an example of taking curved graph data and turning it into a straight line data so that we can use the slope of our linear line to find a desired value. I'm going to use a kinematics example for this. So I have some data here off to the left, drop height versus final velocity. So our scenario could be dropping an object, such as a ball, from different heights and then measuring its velocity just before it hits the ground. Okay, I've got my steps here to take my curve data. As you can see, when I make a graph of this data as it is, it makes a curve. It doesn't go in a straight line. It kind of looks sort of logarithmic, and it just gets shallow and shallower in that change in height as you go up across the graph. So I have my steps here. The first step is to find a physics equation that includes both my x and y axis variables. If it doesn't have both, that's not going to help me. And I've got to rearrange that equation to find into a slope-intercept form that matches the graph I already have made. Then I'm going to have to figure out what my x-axis variable should be, and I already should have figured out what my y-axis variable should be to make it so that the graph will come out linear. That's why we put it in slope-intercept form. Then I'll have to make a calculated column for my new x or y data, whatever has to be changed. Then I'll make my new graph, find the slope value using a trend line, and then set that slope value equal to whatever that number is, equal to the slope formula from the equation I made from that slope-intercept form. And then I can use algebra and solve my desired variable. That's a lot. There's a lot of steps to this. It's kind of a complicated process, but once you've done it a couple of times, it's really not that bad. So I've got my final velocity versus drop height here. I need to find a kinematics equation, and I have three options to that has final velocity and height. It doesn't have really anything else. So this first option has velocity and position, but it has time information. I don't have any time information, so I can't use that one. The next one has velocity final and velocity initial information, which I know is going to be 0. And it has that displacement or our height measurement. So this one's a distinct possibility. And then the last one is an acceleration definition, but again, it has time, and I don't have a measurement of how long this took. But if I take this equation, looks like I can rearrange it, and I can use my graph in order to find acceleration. So I'm going to use this formula. I'm going to write it up here, and I want to rearrange it equal into y equals mx plus b form. So I'm going to rewrite it over here to think. So I'm going to go ahead and put that my initial velocity is 0, and then that way I can rewrite my equation. Okay. So now I've got velocity final squared equals 2ax. I'm going to change that x into an h because we're working with height. And then now it kind of matches what I have. So right now, this already is in velocity, this already is in a slope-intercept form. So I can say this equals y equals mx. So if I make this, that means that my y data should be velocity final squared. My slope is going to be 2a. And then my h is going to be my x values, what goes on my x-axis. And you can kind of see how that lines up when I put in those multiplication symbols. I'll even put what I anticipate my slope to be in parentheses. Great, so that means in order to make this graph of velocity final squared equals 2a graph, in order to make that line, I need a velocity final squared column. So I'm going to insert a column over here on the right, and I'm going to call it final velocity squared. I'm even going to put my unit is meters per second squared. And then I'm going to make it do the math for me. So I'll put an equal sign, and then I'll click on the value that I want to use, and then I will square it. And then I'm going to use the autofill. Great, so now I have done all of these steps. Now I just need to do my graph. So I want drop height versus final velocity squared. And there it is. It's nice and linear. I'm going to cover up our old graph since we don't need it anymore. And I do need a slope. So I need to find a slope value using a trend line. So let's edit the chart. Go to Customize, Series, Trend Line. I want a linear one now that it's a line. And I'm going to use the equation. So this says 19.7. So that means I can say that my slope is 19.7. All right, so if I know that my slope is 19.7, remember I know that I set this up using a slope-intercept form, y being velocity final squared, x being h. So that means that slope, this 19.7 value, is equal to 2 times the acceleration. That's where the m lines up. So I can say this 19.7 is equal to 2 times the acceleration. If I divide that over 9.85, I did is divide that to the other side, I can say that my slope helped me figure out that the acceleration of this object falling to the ground is equal to the acceleration due to gravity. It's roughly 9.8 meters per second. So that's kind of an example of how I could use linearized data. Hopefully this helps. This is sort of a complicated process, but maybe seeing it another time can be helpful.